Welcome to an introduction to Passive House. My name is Ken Levinson, and I'm the Executive Director of the Passive House Network. Thank you for joining this presentation. I hope it leaves you thinking differently about buildings and ready to act. The Passive House Network is a national nonprofit organization that educates and builds peer-to-peer knowledge sharing networks across the U.S. We work in support of professionals working with the International Passive House Standard, and we are affiliated with the Passive House Institute and the International Passive House Association, based in Darmstadt, Germany. We work in collaboration with the North American Certifiers Circle, 20 independent building certifiers working in the international standard who share knowledge and make better buildings together. We connect global knowledge, regional contexts, and the needs of local applications. We connect you to others across the U.S. and around the world. Today, we have 9 regional chapters and hundreds of members, and hope you'll consider joining us too. And we want to encourage everyone to get Passive House training and education, because as you'll see, Passive House education changes the way you think about buildings and work on buildings. Passive House education can transform our building industry culture and empower climate solutions. In this presentation, we'll address the question, why Passive House? What makes it so compelling in the first place? Then we'll look at the logic of Passive House, what makes it tick. From there, we'll dive more deeply into the methodology. We'll talk about the tools we use to make Passive House readily achievable, and we'll finish by looking at a range of examples to inform and inspire. So let's begin with the question, why Passive House? As the Reverend Mariama White Hammond of the Green Justice Coalition and others have said, building is not a neutral act. Buildings are critical to our personal and societal well-being. We spend 90% of our time indoors, and buildings are responsible for 40% of global greenhouse gas emissions. At the same time, the buildings we typically produce are unreliable, expensive to operate, and they make us sick. All of these failures disproportionately affect poor and marginalized communities, exacerbating inequality. And while good building is not a panacea, we need to recognize the power of buildings to either help us in solving our problems or how they will just make our society worse. And this is not hypothetical, as we see growing extreme weather demonstrate how our building infrastructure is failing us. Whether it's heat waves, deep freezes, or wildfires, and their inescapable smoke, there is a simple truth. Either we'll have buildings that are prepared for climate change, or we won't. So in this time of growing extremes, Passive House has us turn to the occupants. We start with the occupants, their comfort, health, and well-being. We need to build for our future, not the past. Passive House also offers the realization, in many ways counterintuitively, that energy efficiency underlies and drives what we value most, our essential project goals: comfort, health, cost-effectiveness, safety, sustainability, social equity, resilience, zero emissions, lower investment risk, and all this need not inhibit beauty. Passive House can deliver all this and more. These are universal wants in many ways and define fundamental performance. Passive House energy efficiency drives these fundamental performance metrics. Passive House drives fundamental performance by empowering the architecture, the enclosure to do the heavy lifting. It's the architecture that establishes fundamental high performance, not the mechanical systems. We see architects, builders, and owners excited with this re-engagement with basic building elements, the details, and the team, and empowering the act of making. It's like a reorientation in a way, and the potential results are limitless. Today, in the move to electrification, our so-called net zero buildings are giant liabilities in that the solar power installed provides excessive energy in the hot months and uses way too much energy in the cold months, producing a sizable gap between production and demand, which we see on the left. Passive House, among its many qualities, crushes the heating demand, allowing for buildings to install less renewables while matching supply and demand more effectively, a boon to both the ratepayers and utility suppliers. Passive House supports our country's transition to a green grid and electrified future. The dramatic energy reduction Passive House buildings provide makes removing fossil fuels from buildings economical, and with renewable energy options available on-site and off-site, Passive House makes grid utilization more efficient and resilient. Consequently, the more passive houses we build, less renewable production is ultimately needed, making our green transition more affordable and more quickly achievable. As forest fires grow, the need to keep smoke out and healthy air in will become more urgent. And with utilities struggling in deep freezes and heat waves, we need to maintain indoor temperatures long enough for us to stay safe while the power supply is fixed. Passive House provides resilience that we can shelter in place indefinitely in the winter and in the summer for an extended period, long enough for the power company to get things up and running again. Passive House supports equity by delivering high-quality, comfortable, and healthy homes that cost dramatically less to operate. The dramatic reduction in energy usage also protects people from possible future energy price shocks. This is an affordable housing development for seniors in Queens, New York, that also has a pre-K school on the ground floor. Passive House first scaled in Europe with affordable housing projects, and today in the US we see affordable housing advocates incentivizing and encouraging Passive House building. Buildings have not just emissions from their ongoing operations, but also from the actual making of the building and the ongoing maintenance of it. The manufacture, transportation, and installation of concrete, steel, mechanical systems, and more all produce carbon emissions. Because Passive House does such a great job crushing operational emissions, the imperative for crushing embodied emissions as well fast becomes the 300-pound gorilla. And with Passive House, using the pH ribbon, we can also optimize embodied carbon reductions while optimizing operational efficiency together for maximum climate impact. Finally, for this portion, it's important to note that Passive House can and does work with existing building codes and many sustainability programs. Your project may have a mix of goals. That's great. Go for them. Just be sure Passive House is there to lock in the fundamental performance benefits we've outlined so far. Okay, so now let's discuss the logic, because frankly, some of this is counterintuitive. The logic is based on continual scientific experimentation and our experiences. And like most fundamental building science, we find it grounded in the strengths of vernacular architecture. How did people stay comfortable and healthy before the Industrial Revolution and the mass extraction of fossil fuels? Passive House, you'll see, draws a great deal from vernacular strategies, and in particular, a study of the vernacular architecture in China by Bo Adamson, a Swedish academic who helped launch the Passive House idea for a research project in Europe. Another interesting, strictly functional example is the Norwegian polar explorer ship, the Fram, which contained all the principal strategies of Passive House building, with fresh air and the occupants' comfort provided by only a single lamp burning. The explorers joked of taking out the stove because it was not needed. In Denmark, the DTH Zero Energy House provided valuable experiences directly incorporated into the start of Passive House research. In Germany, a super-insulated experimental home showed the potential of passive measures providing energy savings on the order of 10 to 20 times in Europe and America. And in the US and Canada, pioneers like Wayne Schick, William Shercliffe, Amory Lovins, and Harold Orr, and others pushed super-insulated developments in the 70s and 80s. These and many more examples were the precursors of the birth of the modern Passive House. So the first modern Passive House was built in 1990 as a research project, a physics experiment, in Darmstadt, Germany, by an international team led by Wolfgang Feist. the founder of the Passive House Institute, and included the pioneer Bo Adamson and many others. It was and is composed of 4 attached row houses, complete with custom building components developed for the experiment. And this research solidified the underlying principles and strategies that would become the Passive House standard. The story goes that Amory Lovins from the Rocky Mountain Institute visited the building and provided the insight that these new developments could be standardized and scaled to great effect on the building industry. And from that time, the Passive House Institute has continually conducted research and developed tools, working with industry and government partners worldwide to make passive house buildings the new normal. What kicked things off was the recognition of an industry disconnect and a need to establish fundamentals to act on. Wolfgang Feist says, "I was working as a physicist. I read that the construction industry had experimented with adding insulation to new buildings and that energy consumption had failed to reduce. This offended me. It was counter to the basic laws of physics. I knew that they must be doing something wrong, so I made it my mission to find out what and to establish what was needed to do it right. To make this more accessible, let's look at cooking. We understand you can have the best ingredients and still cook an awful meal. Cooking, like building, is more than the sum of its parts. To be a great cook, as Salman Asrat has written, you need to master the basic elements of cooking: salt, fat, acid, and heat. And Passive House forces a similar focus on and mastery of the elements that drive building performance. Traditionally, the focus is first on efficiency alone and achieving comfort and health in spite of energy efficiency. But with Passive House, this thinking is turned on its head. With Passive House, the focus is on how efficiency supports occupant comfort and health. And it is this focus on comfort and health that in turn drives efficiency. Passive House starts with the occupant. Per the purely functional, shall we say Platonic or idealized definition, as it was distilled, we quote, "A passive house is a building for which thermal comfort, ISO 7730, can be achieved solely by post-heating or post-cooling of the fresh air mass, which is required to achieve sufficient indoor air quality conditions without the need for additional recirculation of air." This describes maintaining comfort and health with 100% fresh air with a very low capacity for heating and cooling energy. You need a very energy-efficient building to achieve this. Consequently, health, comfort, and efficiency are all supporting each other. In many ways, Passive House is a comfort and health standard driving an energy standard, the Passive House standard. The basic drivers of performance is first the enclosure and its key parts: insulation, thermal bridge-free connections, air tightness, and high-performance windows and doors with good solar control. The enclosure, the architecture is first because the architecture is empowered to do the heavy lifting. Then focus on high-performance heat recovery ventilation, ensuring continuous filtered fresh air with very little energy loss. The occupant comfort criteria and activities are addressed. What makes us comfortable? How about steady temperatures, no drafts, no cold feet, peace and quiet? How about sitting by the window on a cold winter day and feeling comfortable? And finally, the calculated energy balance is tuned to minimize active heating and cooling. These factors of enclosure, ventilation, occupants, and energy balance must be successfully addressed, mastered, and integrated and optimized at every step of the process, each reinforcing the success of the others. The result is a new reality where power and performance are decoupled. With much less power, we provide far greater performance. At the left is a diagram of a home's energy balance, but could be any type of building, with heat losses below the middle line of equilibrium and heat gains above the line. We could also flip this to be about cooling in a hot climate. In the old, very leaky, and modern, shall we say moderately leaky homes, Large active heating systems are required to bring the building into balance, as the gains above must equal the losses below, while the passive house building requires a tiny fraction of the energy to be brought into balance. This dramatic reduction in heating and cooling demand demonstrates the power of the optimized passive architectural structure. We see that the building has done most of the work to bring the energy flows into balance, and it is just topped off with active systems. This new reality will flip our expectations. How do we hit such marks, you may ask? It's because the targets are fixed. The targets are not relative to a baseline, and there is no clearer expression of that high-quality result than a building certification by the Passive House Institute. The calculated energy balance with fixed targets drive predictable performance. Owners, investors, and occupants, you all like predictable performance. And here we see a representative sample of performance outcomes. Building code on the right produces a wide range of outcomes. Green building programs like LEED also provide a wide range of outcomes, while passive house buildings' outcomes are very tightly grouped. Consequently, our traditional code and green buildings require large, oversized heating and cooling systems. In contrast, a passive house can radically and confidently reduce those systems, optimizing your investment. And if there's one thing we want to be as predictable as possible, it's cost. Of course, we're talking about construction, and the vagaries of the marketplace apply to all projects, passive house or not. Let's note that this graph at the left demonstrates the lack of direct correlation between passive houses, the blue dots, and non-passive houses, the black dots, and cost. In these examples, passive house was not an add-on, but an integrated goal, and it shows the average cost of the passive houses to be less expensive. Now, we are not going to set the expectation of being less expensive, but I think there are some key lessons here. First, that there are many factors driving the cost of a building, and if optimized, passive house should be a marginal factor in the overall budget. That as a fully integrated goal, experience shows that the passive house related decisions can actually drive down costs as much as they might raise costs. What we can't do is think of passive house as an add alternate in the bidding process, and don't think of it as an upgrade. This will doom it in the project. Instead, passive house must be a fundamental programmatic item and fully integrated. It is the only way to succeed. And to be clear, making a passive house building is not about making the cheapest building. This is high quality construction made to last, but it is about affordable high quality. However, let's not count on passive house buildings being cheaper. After all, we don't eat as nutritiously as we should, and we don't exercise enough either, at least most of us. And so let's not assume we're going to optimize our passive house enough. It's life, right? So let's aim for affordable, not the cheapest, maybe even a bit more. And what we're seeing is that a 3 to 5% increase in project cost from a reasonable baseline can be expected. If the increase is greater than 5%, then the decisions need to be re-examined as something went off the rails in the design and decision-making process. We encourage you to download and read our reports shown here that address project costs. Let's say a few brief words on staying on budget. To stay on budget, passive house must be included at the very conception of the project, not introduced in CDs or DD, or even in schematic design. Passive house must be included in the pre-design programming work. You really must work with a certified passive house designer, and preferably the building certifier from the beginning, particularly in your first passive house projects, so you can benefit from their institutional knowledge. Don't dig a hole on day one that you will have to then later get yourself out of. Require the team of professionals and builders to have proper passive house training. The engineer and architect should be certified passive house designers too, and the builder should be a certified passive house tradesperson. Passive house expertise is needed to effectively optimize throughout the project process, and optimize from the start and stick to getting certified, stick to the target. And if team members are feeling like something is just too tough or seems impossible, it could be that a lack of experience and known references is inhibiting them. Get them to reach out, find examples and experiences around the world. They are out there, because while Passive House is young, there is a world of experience to benefit from. The global Passive House community is generous in sharing information. Use it. We can't be islands and succeed. And let's be clear, if you are diligent and eat your spinach and run those laps, you can come in at traditional building costs, or maybe even be less expensive. So let's look at the methodology that makes all of this possible and dive into some of the details. We start with the enclosure and insulation, right-sized, climate-specific, continuous insulation. Generally, this means more insulation than normal, but not always. The idea is that you want to insulate to a level where you don't just shiver less, but you are actually comfortable. Typical buildings are like an underdressed teenager wearing nothing but a hoodie in midwinter. They'll survive, but do we want to live like that? You know that if you wear the right layers and a good parka and a hat and so on, you can not just get by in the cold, but actually be warm and comfortable. Our Passive House is the same way. Or think of it as a temperature-rated sleeping bag or a bird that insulates itself in winter. Our buildings should bundle up for the weather. Then let's get rigorous about bundling up and make sure we don't have interruptions in the insulation. In typical construction, enclosure component connections interrupt the insulation continuity and let massive amounts of energy escape. These interruptions are called thermal bridges. At wall and floor connections or roof connections, balconies, and structures, thermal bridges can abound. In isolation, these breaks in insulation may not seem important, but they can completely undermine the building's performance. If we think of a thermal bridge as a cut, your project can easily die from 1,000 thermal bridge cuts if you're not very careful. The colder interior surfaces can cause condensation and mold. To overcome them, typically we overheat, treating the symptom with brute mechanical force. With Passive House, we avoid the problem in the first place. Now let's look at the enclosure airtightness. And when the subject comes up, people might reflexively touch their necks and worry about poor indoor air quality and perhaps succumb to nightmarish imaginings of not being able to open windows. We need to set the record straight at the start. Two concepts are in play: quality indoor air and our freedom to do as we like. And so we need to flip the common and wrong-headed thinking on both of these. First, let's address quality. The fundamental idea at work here is that it's very difficult to control the quality of something if you don't first have control of the thing itself. If the enclosure is leaky, the polluted outdoor air, including forest fire smoke, is moving willy-nilly through the building. Consequently, in our typical leaky buildings, the only way to have any sense of control is to overcome it with power, never sure if this space or that space is properly ventilated. Like thermal bridges, we're typically treating the symptoms with more brute force. But in an airtight environment, the air is under control, and we can then very efficiently and confidently maintain its quality. Airtightness sets the table for healthy indoor environments. But you say, that's all well and good, but the Passive House police won't let me open the windows. The reality is quite the opposite. You can, in fact, open the windows, and natural ventilation should be a part of the building performance strategy when outdoor conditions make sense. Let's face it, in typical buildings, you may not want to open the windows due to outdoor pollution or the weather, but you need to. Whereas in a Passive House, you have clean, fresh air whether the window is open or closed. You don't need to open the window. You open a window because you choose to. It's a lovely day. Open the windows and let the breeze blow through. Passive House, counterintuitively, is actually giving you the freedom to choose. So with that set straight, let's take a moment to talk a bit more about why airtightness is so important. And it's because it profoundly affects so many fundamental aspects of building performance. We've just spoken about it supporting indoor air quality. What about comfort? Well, it eliminates those annoying drafts we need to overcome with enlarged mechanical systems, more brute force treating symptoms. Airtightness also protects the enclosure from moisture damages. It is not generally understood or appreciated that air moving through the enclosure leaks can carry massive amounts of moisture with it, producing another source of rot and mold, and is a leading cause of building damage insurance claims. So by making the enclosure more airtight, we reduce moisture damage risk and we increase durability. And airtightness radically reduces heat loss. If we take two buildings, both well insulated equally, but one is leaky and the other airtight, the difference in heat loss could easily exceed a magnitude of 5 times. You heard that right, 5 times the difference. They become totally different buildings based on airtightness alone. Airtightness, like a windbreaker over a fleece sweater on a cold autumn day, optimizes performance. And so if in your energy calculations, design, and construction, you can confidently provide greater airtightness, don't just hit Passive House airtightness, go hit twice the airtightness. That first Passive House in 1990 did, and you can achieve huge enclosure cost optimization, construction savings, and greater design flexibility. In hot, humid conditions or climates, airtightness keeps the humidity out and reduces the demand for dehumidification, allowing the cooling system to be sized mostly for cooling, as it should be. Finally, where air leaks, noise also travels. If you are in a noisy environment in the city or in the country, Passive House airtightness delivers peace and quiet. You can hear yourself think again. For all these reasons, the truth is that a building can never be too airtight, and Passive House takes full advantage of this truth. Airtightness is a Passive House superpower that you can make your superpower. The importance of high-performance quality windows with high-quality installation and solar protection, all fully integrated and optimized in the building's energy balance, cannot be overstated. They not only provide passive heat gains, daylight, and views, but are a critical component of the continuous insulation and airtightness layers that completes our high-performance enclosure. The windows themselves are often triple pane and truly thermally broken and airtight with 3 layers of gasketing. And the window connections to the surrounding construction, the connection to the surrounding airtight and insulation control layers must be airtight and insulated. Thermal bridge-free connections, of course. This all gets you deep into the construction details, into the connections and the power of those architectural details. Passive House windows can come in any type: metal, wood, metal-clad wood, PVC, and fiberglass. There are dozens of suppliers to the U.S. market today, and there are several North American manufacturers producing Passive House certified units. Be sure to check out the certified component database on the PHI website, passivehouse.com. Glazing can be big and plentiful if you use high-quality components, but it must always be carefully calculated in the energy balance. And we need to distinguish what we're doing here from the many so-called passive solar buildings built in the 1970s that were often overglazed to get passive heating, but were out of balance and often uncomfortable. Please remember that the term passive solar does not equal Passive House. So while we like wintertime passive solar heat gains, no doubt about it, we need to avoid overglazing and provide solar protection and prevent overheating. Windows drive overall building performance outcomes, energy balance optimization, and occupant comfort in ways that may not be appreciated when you set out, but as you work through the process, you will grow to appreciate it very much. Window quality is a primary driver of comfort, and while there are a myriad of factors, the fundamental idea here is that our typical windows result in significant temperature asymmetry. In winter, the window is colder than the other room surfaces, and you feel it. It causes convective currents, and this needs to be overcome with perimeter mechanical systems. The common sad refrain of more power treating symptoms. With Passive House, the windows are of a quality that the temperature is close enough to avoid discomfort and avoid the need for mechanical systems to compensate. Because windows are such a critical component and their performance cannot be compromised, we recommend that Passive House Institute certified windows are utilized. Like airtightness, high-performance windows disproportionately affect the overall energy balance performance of the building. They offer greater design freedom, flexibility, and options. They provide value that cannot be appreciated in an isolated budget line. Good solar protection means good shading. This is fundamental building science. You sit under an umbrella at the beach for a reason. Traditionally, the answer has been to ignore it and to turn the AC up to 11. But unlike conventional buildings, we are looking to minimize our active cooling too. The less active cooling required, the more safe and resilient our building will be. So we must actually consider shading and integrate it into our Passive House building design. Shading can be provided by how the window sits in the wall, an architectural element, or landscaping. Needed shading can be achieved with interior blinds, but exterior shading is the most effective. Shading cannot be an afterthought. Solar shading cannot be optional. Ignore shading at your peril. With the high-performance enclosure established, we want to ensure good indoor air quality with hygienic ventilation, a primary goal baked into the definition of Passive House. Today, in coping with the COVID-19 pandemic, hygienic ventilation is a hot topic. Add to that the inescapable forest fire smoke and the long history of poor health outcomes for marginalized communities on the fence line of industrial production. And it is clear that hygienic ventilation should be a foundational goal. Now, typical buildings have ventilation mechanical systems, just bad ones, often providing only intermittent exhaust from bathrooms and kitchens that don't ensure good ventilation everywhere. And in commercial buildings, the ventilation system often includes a lot of recirculated air. In a Passive House building, we supply 100% filtered fresh air to every served space, the bedrooms, living rooms, offices, classrooms, and so on, and 100% exhaust from every service area, the bathrooms, kitchens, utility areas, etc., operating continuously 24/7. The systems are laid out to ensure that all spaces have robust ventilation. And again, there's zero recirculation. Now, such a system of 100% air changes would normally be prohibitively expensive to operate because typically you need to heat or cool that fresh air to maintain comfortable indoor conditions. But this gives us the passive in ventilation because there is a passive heat exchange element located with the fan unit that allows the heat and energy from the outgoing airstream to move to the incoming airstream. And today, the efficiency of this passive exchange can exceed 90%. This means that on a cold winter day, the fresh air supply without any added heat enters the room within just a few degrees of the room temperature, ensuring occupant comfort. And Passive House Institute certified ventilation units ensure that you get the performance and cost savings you expect. Now let's reiterate. As we noted with windows, you can and should consider natural ventilation strategies with your Passive House design, but the issue is that you can't count on natural ventilation. The weather or exterior conditions may not cooperate. Then what? With Passive House, you establish fundamental high-quality indoor air for people no matter what's going on outside. So this complementary focus on the enclosure and ventilation, we have established the guts of the building's fundamental high performance for people. This is about our comfort and health at the end of the day. The activities will be considered along with the comfort criteria, which exists for windows and surface temperatures in general, but comfort criteria exists for ventilation and noise of mechanical systems too. We want people to love being in a passive house. Now, as we are planning and designing, specifying, detailing, and building, we are from the start entering all of these decisions about the enclosure, ventilation, and occupants into the Passive House Energy Model, called the Passive House Planning Package, or PHPP for short. With the model, we can actively optimize design decisions, component selections, and budgets. Better windows or greater air tightness can mean less insulation being required, for example. Whatever configuration makes your best design, one thing will be consistent and predictable, and that is hitting the targets of dramatically lower energy use and occupant satisfaction. Because the integrated and calculated performance is predictable, passive house mechanicals are no longer compensating for a poorly performing enclosure and ventilation system. Consequently, we can radically reduce the heating and cooling systems with confidence. We can make the distribution more efficient, pulling back from the perimeter to the core of the building. The architecture is driving the building performance. And let's not forget renewables and smart systems. Renewables are not only compatible with Passive House, but are integrated into the Passive House Plus and Premium certification criteria. Similarly, smart systems, while not mandated, are completely simpatico. The critical point here is that they are integrated to enhance high performance and not to compensate for poor performance. First, you want to establish the drivers of your great meal and then introduce the jazz band. Let's look briefly at some of the key tools to help you get started. The PHPP Energy Model is the Rosetta Stone for understanding energy balance implications of design and construction decisions and gives you control. Supplementing that are other programs like the SketchUp-based Design PH and BIM2 PH softwares. We cannot understate how important training is to getting this right. It's not rocket science, it's truly basic building stuff. But unless you get trained, it's hard to know what you don't know. And with some basic training, you'll emerge with a new vocabulary, having new conversations and asking new questions, and never looking at buildings the same way again. It seems extraordinary because it is. Don't wing it. Training is the driver of optimized design, processes, and budgets. We hold regular hybrid online certified passive house designer trainings and other specialized trainings in PHPP and more. Our friends at EMU provide excellent certified passive house tradesperson training. These trainings are valid for amateurs and professionals alike. You just need to want to go for it, and we encourage you to go for it. In addition to professional certifications, there are certified components scored to different climate zones. It's not a requirement to use certified components, but PHI and certifying mission-critical components give teams clearer paths and greater confidence to reach the goals more readily and predictably. Be sure to check out the component database on PHI's website. And then there's building certification for both new builds and retrofits of existing buildings. Everything is possible. Dive into the PHI criteria for buildings documents. It's surprisingly compact and lays out the specific targets for heating, cooling, air tightness, comfort criteria, and more that form the matrix of building certification. We also want you to be aware that it's not just PHI that certifies passive house buildings, but an accredited network of professionals numbering over 100 around the world that provide building certification services. In the US, there are over 15 organizations and 20 individuals working on building certification and form the North American Certifiers Circle. Go to our building certification webpage and find out more about it. There are a variety of on-site tools, but none is more important than the blower door. When you build passive house airtight, you can successfully test the 24-story Cornell Tech building with 1 door and 2 fans. That's something. At the end of the day, this is all just basic building science. It's practically all from vernacular architecture. Remember the 19th century Arctic explorers knew how to do it? This has evolved globally over decades, and we see it being successfully applied worldwide. These universal drivers of building performance have local solutions and expression. So let's have a little fun and take a quick run around some projects. We've got tall ones here in Vancouver, New York City, and Boston. Affordable housing and Passive House make a great pair addressing social inequity, ensuring that the people that need better performing housing the most actually get it. And here's social housing in the UK that won the prestigious architectural Stirling Prize. Museums and other civic institutions, including a project in Vancouver by Starkitects, Herzog and de Meuron. Government buildings, including the Belgian Embassy in Kinshasa and Brussels Environment Ministry building in Belgium. A gorgeous and deceptively simple document archive building by Archetype in the UK, and many university buildings here in Maine, and a retrofit at Cambridge University, among many others. Are you doing a recreation center and don't think it can be Passive House? Well, it can be, and it should be. And finally, believe it or not, you can actually make single-family homes a Passive House too. New build or retrofits in the north and the south, in the east and the west. Home should be a Passive House. I hope you've enjoyed this introduction to Passive House. Please don't be overwhelmed with the challenges ahead. Get trained and build your future. We're here to help you make it happen. I hope to see you soon. Thank you.